Okay, hi class. So today we are down to the last worksheet 4 of this chapter. Okay, and in chapter 13.6 in the last part, we're going to combine whatever that you have learned in the previous segments on the volume and surface area of a prism, which is you have already learned the formula, okay, to how to calculate it, and the volume surface area of a cylinder. Now, what we're going to do in this lesson is that we will combine everything that you have learned, and then we are going to learn how to calculate volume and surface area of composite figures. Now, what does composite figures means? Okay, composite figures like what you see right here is actually a shape that cannot be defined as prism or cylinder. It is actually a mixture of both of them. I cut a bit of a prism and then maybe a quarter or rather a full cylinder, then I stack them together and I form a new shape. Okay, so that's what we call a composite figure. Alright, okay, so this is a video recording, so I will just go through all the questions, and then if let's say you need time to copy, you may pause the video and or even scroll back and look through. Okay, alternatively, if you want to, you can refer to the OneNote because the worksheet will also be uploaded right there. Alright, okay, so we're gonna start. First one. Okay, the figure shows, in example 1, the figure shows a closed container. So I want you guys to highlight this. Closed, take note, meaning that all the sides are covered and it has a uniform cross-section area. Okay, so you need to identify where is the uniform cross-section area. It is right here. Okay, this is the uniform cross-section area because when you take a knife and you chop it across, you're gonna get a surface that is exactly the same as the first one and the last one as well. The front and the back, sorry. Okay. Right, sorry about that. I will now continue with the lesson. Okay, sorry about the notification. Yeah. So part 1, volume. Okay, so I'm gonna write down first. Remember, you must always explain what you're writing. So the volume of this shape, how do I calculate it? So I look at this. I can actually draw another dotted line right here. And then do you see that the red color part is actually okay, the red color part is actually a cuboid. Okay, so to find the the volume of a cuboid, I will just have to take 20 times 9 times 14, and then I need to add in this side over here. This is a cylinder, but it's 90 degree here, right? Okay, because they say it's a quadrant, meaning that is a quadrant here means that is 1/4. 1/4 of what? Okay, of the full volume of a cylinder. So how do I do that? I need to first know the formula for the volume of a cylinder, which is pi r square, which is 14 here, because they have given to you that this is 14, so this is also 14 and this is also 14. Okay, so pi r square times the h, the height will be here. Okay, the distance between the two faces, two cross-section area, so times 20. So what I get here is 2520 plus 980 pi. Okay, and then did the answer ask us to leave our answer in pi? No, right? So we need to calculate it, and we will have to round it off to 3SF. We get 5600 cm cube, 3SF. Okay, second part, they ask us to find the total surface area. Okay, in order for us to find the total surface area of the container, okay, total surface area of the container, I'm gonna clean it up. We need to make sure we know how many faces are there. Okay, so first we need to find out the cross-section area. Find the area of the cross-section first. So how do I find that? There are two of them, right? Okay, two of the cross-section area. So two of the cross-section area, first I add in the rectangle right here, and then this is a quarter of a circle, so it's 1/4 pi 14 square. Okay, understand? Okay, so this is actually, I'm gonna erase it after I write, okay? This is actually finding, sorry, not here, just right here. This is actually finding the cross section area. Okay, this is finding the cross section area. Then after that, remember what I told you guys about finding the faces other than the cross section, the side here and the one opposite. Okay, basically the entire round go round. So I want you to imagine, just like what I said last time, you take a scissor. Let's say this is formed by paper. You take a scissor, you go and cut here and you open it up, and this also flatten it down. In a net diagram, you're gonna get a big rectangle. So in order to find the surface area of a rectangle, all you need to do is just find the perimeter of the curved surface of the cross-section area multiplied by the height. So that's exactly what we're going to do. Okay, so the perimeter will be this plus this plus this and this. Okay, so it's 9 plus 9 plus 14 plus 14 plus this part. How do I calculate? Okay, they say that it's a quadrant, so it's 1 over 4 times the circumference of a circle, which is 2 pi r. Okay, radius is the radius is 14. Okay, and then this is the perimeter of cross section. Okay, this is a formula that we also learned before. And then take this entire thing, multiply by 20. Okay, so what do we get here? We should get it as 1920 cm square, rounded off to 3 significant figure if you key everything into your calculator correctly. Okay, now of course there is another way of doing it, is to calculate, separate it face by face, one by one, and calculate. I mean, you can also do that. It's not wrong. You will have to write a little bit more stuff, but it's the same thing. Okay, so what I'm showing you on the screen might not be the only way of doing it. Okay, next question. Example 2. The figure shows a rectangular prism of dimension 12 cm by 6 by 8 with half a cylinder of diameter 6 cm horizontally carved out of it. So rather than putting in a cylinder here, they actually cut the cylinder away from this shape. Okay, so they want to, number one, ask you to find the volume. Okay, now to find the volume of this, we need to minus away the volume of the cylinder, but it's not the entire cylinder. Okay, this is solid. This is not the entire cylinder. I want to take a look at this shape. Okay, this is definitely started off as a cuboid, right? So if I draw it out, the dotted line there, it started off a cuboid. So why not we just take the volume of a cuboid and then we minus away the cylinder. But they say it's half a cylinder. Do you notice it? Highlight. So these are very important words. So half the volume of a cylinder. Okay, because the diameter is 6, right? So we know that the radius is 3. The distance between them is 12. So the height of the cylinder is also 12. So here, when we calculate, you will get 406 cm cube, 3 significant figure. Okay, next part, total surface area. Okay, so we take a look here. Total surface area. I'm going to erase a dotted line. It's easy for us to calculate the side here. If I draw a dotted line, so we need to have good imagination, able to see 3D shape. So the 1, the 2, the sides that you cannot see at the back and at the bottom, and of course this one here are 3 sides that are easy to find because they're rectangle. But what about the rest? Okay, the rest are not so simple, so we need to take a look. Let's find the easy one first. The side here, this is an easy one, and there are 2 of them. Agree? So therefore, what I can do is I just calculate that first. 2 times 8 times 12. Okay? Right. Then after that, find another easy one first. What's the easy one here? The bottom. Okay, I believe some of you have gotten it also. The bottom is also another easy one, but there's only one of them because the top got cut out a hole already, right? So I will have 6 times 12. Okay, what else? Okay, the next one. What else do you think is an easy one to calculate? Yes, this side. There are 2 of them. Okay, so basically you just need to calculate area of a rectangle minus half a circle. Okay, so I put a big square bracket, area of a rectangle, so 8 times 6 minus half times pi r square. Okay, and how many of them? There are 2, so I need to write the 2 in front. Okay, because there are 2 of them. Then after that, I take this whole thing. Yeah. Dotted line. Then after that, I take this whole area that is curved. This whole thing here, I need to calculate it out. Then of course the curve here. Okay, that will be the curved surface area. Okay, so now I want you to think of cylinder. This is the more difficult one. How do you find the curved surface area of a cylinder? Okay, we learned before. It will be the circumference times height, right? To find the curved surface area. Okay, and the circumference is always pi r squared. Okay, if this radius r, if this is h. Okay, because it's a circle, right? Pi r squared times height. So curved surface area is basically pi r, sorry, not pi r squared. It's 2 pi r. So yeah, 2 pi r, so it's 2 pi r h. So we know that it is 2 pi r h, and we cut it into half. So what do you think is the curved surface area in our question? Okay, so it's just taking this number multiplied by a half. Okay, so we need to plus half times, okay, let me erase this, 2 pi r h. Okay, the radius is 3, height is 12. So if you calculate it out, you get that this is 445 cm squared corrected to 3 significant figure. Okay. Now example 3. The diagram shows a regular hexagon that made out of 6 identical, highlight, 6 identical equilateral triangles. Alright, okay, every side is 2 cm. The height of each triangle is 1.732. Find the area of the regular hexagon. Okay, so read the rest later. We need to do, so there are many parts. We need to do part A first. Okay, so they ask us to find area of regular hexagon. Okay, so they are all same size. Can you go back, look at your worksheet and go and count how many triangles are there? Yep, there are 6 times half. Okay, the area of a triangle, half times base times height times base times height, the perpendicular height 1.732 So I get 10.392 cm squared. There's no need to put 3SF, no need to round off because this is an exact number. Okay. Now part B. In the figure below, a trapezoidal prism has a hole drilled to it. The hole has a uniform, the hole has a uniform cross-section area. It's the same as the hexagon in part A. Okay, and all the units are in cm. Calculate the cross-section area of the solid. Alright, now they just want you to calculate this face. So in other words, you just need to know how to calculate the area of a trapezium minus away the regular hexagon. So, need to write down a statement. Please follow me here. Cross-section area will be equals to area of trapezium minus area of regular hexagon. Okay, so the area of the trapezium, if you look at it, I hope you still remember, is half times the top and bottom, which is the two parallel sides, add together, multiply by height. Okay, minus away the trapezium, this one no need to calculate. We already found out in the first part, so you just have to copy it out here. Okay, because it's the same thing. You get then this is 11 point, sorry, you get this is 117.608 cm squared. Do I need to round off? Nope, because it is an exact number. Okay, last part. Looks complicated, this whole question. But then again, you check and you see carefully. The volume of the solid giving your answer to two significant figures. You have already found a cross-section area. If you want to find volume, what do you do? Just multiply by the height. Okay, so volume of solid will be equal to 117.608 multiplied by 20. 2352.16. So the answer is 2400 cm cube, rounded off to two significant figure. Okay. Now the last example of the worksheet, and then we are done with this chapter. They're asking you to find the volume. Okay, so let's read the question first. Maintain a good habit. Okay, so they say that it is a solid. This solid has is a cylinder. Radius 2.5. Okay. Height 8 cm. Okay. And then a cuboid with this dimension. You have a cuboid at the bottom. 1, 2, 3. Alright. So they want you to find volume. Actually, based on the words there, it's very clear that they intend to ask you to find the volume in two separate parts. Okay, the cylinder and the cuboid. Okay, let's do the cylinder first. The formula to find the volume is pi r squared h. Okay, this is to find the cylinder. And the cuboid is 7 times 11 times 3. And this will be for the cuboid. So what we get here, when you calculate it out, is 388.08. Now this is not an exact value, so we need to round it off to 3SF. This will be 5SF. Next, total surface area. How do we calculate total surface area? We can no longer use the trick that we learned last time, that you take cross-section area, then you divide by, that you find the perimeter or the circumference of the cross-section area, then you times height. You can no longer do that because there is no cross-section area. Okay, sorry, there is no uniform cross-section area because it's different at different sides no matter how you cut it, right? You cannot find one side that's the same. So there's no choice, you have to add all of them one by one. Okay. I like to do my work a bit more systematically, so I will count from the top to the bottom. Okay, I'll do it one by one. First, I'm going to start counting this side here on the top. So the circle at the top, how do I calculate? Okay, what's the formula to calculate? So I will calculate 2.5. Actually, you think about it, there is a way to see these questions. Okay, you look at the top. Can I then calculate? Let me draw it out for you to see. You see carefully, this face here and this face here, and the ones, maybe there was a circle, the ones at the back. If you see from the top, okay, if your eyes are here, you see from the top, what do you see? You just see a rectangle. Okay, so actually you don't even need to calculate the face of the circle, because it's actually a rectangle but with these cylinder pop up. So the total surface area, you actually can just calculate a rectangle, this rectangle here, and this rectangle area. You don't need to minus the circle because the circle is right there. Okay, when you stick it together, it is the same thing. So I just need to calculate 7 times 11. Okay, I'll calculate the rectangle at the top. But how many rectangles are there? There are 2 of them. Okay, because there is 1 at the bottom also. Okay, then I need to calculate the curved surface area. Remember the formula is 2 pi r times h. Okay, then after that, I need to calculate this face here. This is 3 cm, right? Okay, and this is 7 cm. So 3 times 7, how many of them are there? 2. Okay, then I need to plus this face here. How many of them are there? 11 times 3, 2. Okay, so by doing this, I've calculated, by doing this, I've already calculated everything here. Okay, let me quickly punch this in the calculator. Okay, what you get here is 387.66 5SF, and my final answer is 388 cm square 3SF. Okay, so because I'm not in school, I will need you to submit your your homework via Teams, via Microsoft Teams. Okay, I will give you until this Thursday. Okay, you want to submit midnight also can, but you must make sure that you submit by this Thursday. Alright, okay, that is all.